Okay, now let us see something called as symmetric and skew symmetric matrices. Okay, and then we'll see about your determinants. First, let us see about your symmetric matrix. Now, what is called as a symmetric matrix? Let me give an example for this. A is equivalent to 2, 3, 7. This becomes 3. This becomes 7. 4, 5. This becomes 8. This becomes 8. Okay, this is the given matrix. This is the given matrix. Now, what do you observe here? Yes, this is a given matrix. So, what do you observe here? The elements opposite to the diagonal elements or opposite to the diagonal are going to be same. This are all going to be identical. Now, this kind of a matrix is called as a symmetric matrix. Whenever the elements across the diagonal are going to be same, this kind of a matrix is called as a symmetric matrix. Now, in the question they're telling, if there is a symmetric matrix, what is the transpose of that symmetric matrix going to be? So, transpose of symmetric matrix is going to be A transpose. A transpose will also be equivalent to the given matrix. What happens in transpose? Rows and columns interchange. So rows you can write it as 2, 3, 7. This becomes 3, 7. This becomes 4, 8. This becomes 8, 5. It remains the same. A equivalent to A transpose. So this kind of questions they ask. A single mark question. Okay. In the worst case, given is a matrix and they ask you to find what is 5A plus 3A transpose. So now what you can do? It is nothing but all equivalent to 8A. You can directly multiply this by 8 and you can finish this example. So you need not separately calculate it and then add it or not. You can directly add these two numbers and you can find the. Makes sense? Fine. So this kind of a thing is called as a symmetric matrix. Now, under symmetric matrix, there are certain things to remember. I'll just let you know those. Okay. Now, the given is a symmetric matrix. There are certain properties of. The first property tells the eigenvalues of the given matrix are always going to be positive. Now, what does an eigenvalue mean? For this, I just need to explain what is it. So, EIGEN, eigenvalues. Okay, eigenvalues of the given matrix is always going to be positive. So, eigenvalues, how do I calculate it? Is A minus lambda I determinant. Okay, determinant of A minus lambda I is going to be equivalent to 0. Okay, where this I is nothing but an identity matrix. I is nothing but an identity matrix. All these things they won't ask in exam. Just for understanding purpose, I am telling how to calculate it and what are these positive values all of. Okay, now imagine my A is equivalent to 5, 4, 1 and 2. Okay, now I need to find the eigenvalues of. So how will I do it? So I can put as A minus lambda I determinant is equivalent to A. I can write it as 5, 4, 1, 2 and lambda I is nothing but lambda into identity matrix. Identity matrix nothing but 1, 0, 0, 1. This is an identity matrix, the whole determinant. Now this can be further written as 5, 4, 1, 2. All these steps I'm just writing it for your understanding. So minus lambda 0, 0 lambda, right? The entire determinant of it. Okay. So this can be further simplified as 5 minus lambda, 4, 1, 2 minus lambda. Determinant. Now, first I need to know how to calculate a determinant. Sir, everything you're telling how to calculate a determinant, don't tell me. Okay. Now imagine this is a given number 1, 2, 3, 4. 1, 2, 3, 4. In order to calculate the determinants, what we'll be doing is determinant of this. Cross multiply. 1 into 4 is 4. And 3 into 2 is 6. 4 minus 6 is minus 2. This is going to be the determinant of this. Fine. The same way, here I can do 5 minus lambda is going to be something like 5 minus lambda into 2 minus lambda minus 4 into 1 is nothing but 4. Fine. Now this can be written as 10 minus 5 lambda minus 2 lambda. It can be written as minus 7 lambda. Okay, minus 7 lambda. Then I'm going to write it as lambda into lambda will become lambda square. Lambda square, yes, minus 4 equal to 0. Yes, this entire term is equal to 0. Or this can be further simplified as lambda square minus 7 lambda plus 6 equal to 0. So can I solve this quadratic equation now? If I solve this quadratic equation, so this is 6. So I can write it as lambda. 6 can be written in terms of 6 into 1 and minus into minus will make it plus 6 and this will become minus 6 plus minus 1 will become minus 7. So it becomes lambda equal to 6 or lambda equal to. So these are two values which are positive. These are called as the eigenvalues. That is what was given in the statement. In a symmetric matrix, always the eigenvalues will be positive. positive. Here, I had just taken an example as 5, 4, 1. But if you take the actual symmetric matrix and you try to solve it, you will get the eigenvalues as positive numbers. Fine. Real and positive, not imaginary. Real and positive. These are called as the eigenvalues. Next. So now there is something called as an A inverse. A inverse is nothing but adjoint A. Okay. Adjoint of A. 1 second. Okay. That will look it in detail. Okay. Adjoint of A divided by determinant of. So how to calculate the determinant I just said. So how to calculate the adjoint of A? That also let us. Adjoint of A. Let us see. No, just a minute, guys. Okay. So adjoint of A. I'll just take it up with an example. So let it be something like 4, 5. No, 4, 5 and 1, 2. Okay. 4, 5, 1, 2. This is A. This is the given example for A. Now, in adjoint of A, what I'll do is I will just do it as swap these both things, and I will change the signature for these both, or I'll change the sign for these. For example, if I swap these both elements, this becomes 2, 4, 2 and 4. And if I change, these two are positive signs now, I'll change it to -5 and -. Now this becomes the adjoint of the given element or the given matrix. Now, sir, is there any other way? Yes, there is another way, but that will be a lengthy one. And this is a short trick which you can use it for the exam purpose. Okay, you need not stick on with something else. So now, if it is for a 3x3 matrix, what will happen is the signs will change, become as minus, plus, minus, plus, minus, plus. Okay, I'll take up an example for that. Just a minute. So 3x3, I'll just like show you some example. So right now we'll just stick on this. Okay, it's all just like remember the 2x2 thing for the 3x3 thing. Okay, adjoint is done. For now, for the determinant of A, this is going to be 4. 4 into 2 is going to be 8. -5 is going to be 3. So this is going to be A inverse is nothing but 1/3 divided by 2 minus 5 minus 1. This is going to be the A inverse of the given matrix. Fine. This is another important thing. And a rule based on this is going to be A into A inverse is going to be equivalent to A inverse into A. That is always going to be equivalent to identity matrix. Okay? A into A inverse equivalent to A inverse into A. That is always going to be equivalent to identity matrix. Okay. So in the exam, they might ask if I'm having a matrix and when I multiply it with the inverse of it, so what will I get? So you will end up with an identity matrix. You can directly write it down as 1, 0, 0, 1. If it is a 2x2 matrix, if it is 3x3 matrix, you can go with the other option. Fine. These are some properties. Now,
sir,
yes.
Sir, suppose this is only applicable when A into A inverse is equal to A inverse into A. Then it is
yes. Not for
if
A
it is
into B. Not for A into B is not equivalent to B into A. That's what I said earlier itself. It is only applicable for the same matrix. A inverse, A. That's it. Not for something else. Okay. Next, an examination problem, a small problem. It is not like an actual thing also. 2 minus 1 plus 2x, 2 minus 1 and 2. Okay. Is equivalent to -1, 3, 1, 1. So find the value of x. Find the value of x. X is equal to what? They are telling we are adding two matrix in order to get the resultant matrix.
-1 or minus 1, sir?
-1, right? So here you can directly take it up. So you need not solve anything. You can directly take up these three values. X square plus 2x equal to -1, or x square plus 2x plus 1 equal to 0, or x plus 1 into x plus 1 equal to 0, or x is equal to -1, right? This is the answer for this. Very simple and straightforward question. Now, we need to understand certain rules of this determinants also. Before that, let me put up an example here. A is equal to 0, 0, 2, 3. Okay. In another case, B is equal to 0, 0, 4, 5, 0, 0, 4. Okay. Now, whenever a particular row or a particular column, all the elements of that particular row or the particular column is 0, the rank of the matrix is the remaining rows. So the rank of the matrix nothing but you having the entire row as 0. So remaining rows are 1. The rank of the matrix is going to be 1. And in case of B matrix also, the rank of the matrix is going to be, okay. This is called as a rank. So they will ask or they might not ask. They will just ask the rules of the ranks, the rules of the ranks. That if you remember, that is more than sufficient. Else rank of matrix calculation. I will also show an example how to calculate the rank. You can just remember it in case if they ask it in the worst case scenario. Okay. Now, whenever determinant. Okay. What's the determinant of this matrix? A matrix. What's the determinant of the A matrix? What? 0. What's the determinant of the 0 of the B matrix?
0.
0. Whenever the determinant of the matrix is 0, such a matrix is called as a singular matrix. Such a matrix is called as a singular matrix. Very important. In question, they mention the given is a, for example, A is so and so matrix is a singular matrix. Then find out the value of X. Then find out the value of X. They give it this way. Example, take this question. A is equal to 1, minus 2, 3, 1, 2, 1, X, 2, and minus 3. Okay. This is the given matrix. And they are telling is if A is equivalent to so much is a singular matrix, then find X, Okay. Now, how do you proceed with this question is first of all,